welcome back. Here we are, 1, 2, introduction to the parent functions. Okay, so what different types of transformations did we discuss last time? So we did three of them. So we did translations. Let's see, translations, which was your up and down or left and right, or both. So it could shift. It's just like a slide, up, down, left, right, moving like that. So we also had reflections, and we only reflected across the x-axis last time. There are reflections across the y-axis as well, but last time we just discussed across the x-axis. So what that does is it takes your xy coordinate and it just makes the y the opposite. And then the other thing was the stretch and compression. So this is indicated by the number in front of the x. So if it was a stretch, that number was greater than 1, right? So it might say like y equals 4x, and that would be 4 times as steep. And then compression is when that number in front of the x is between 0 and 1. So that smushes your graph vertically. All right. So here are the different parent functions, the families of functions. Ooh. So linear is the one you're probably most familiar with. It is just a straight line, and most of the time you see it in like the slope-intercept form. And sometimes you don't, but the important thing is like it's x to the first power. So that's how you know that it will be a linear function. Um, Quadratic function is when you have x to the second power, and that creates a u shape, which is called a parabola. So if it's positive x squared, it's going to be a u shape. If it's negative x squared, it would just be an upside down u. I'm going to scooch down here in a minute. Well, you know what? Not a minute. How about 2 seconds? Cubic, you'll look, and it goes whoop, from left to right, swoops up like that. It's kind of like if you took the quadratic and just flipped down the left side of it. So it's something to the third power, swoops up into the right. And then the last one, the square root of x, it looks like half of a parabola on its side. So now let's talk about this domain and range, which we'll get to more in the second half of this lesson. Domain are all your x values, and then your range are all your y values. So it's like, are there any limits on your x? So if you look at the linear, x is left and right, right? There's no limit. It can go on forever to the left, forever to the right. So they put this r, which means all real numbers. A lot of times you'll see me just write a capital R with like a line down the side like that. Range, your y values, again, there's no limit up and down. This thing goes on forever, so it could be anything. So linear, it's the domain and range are all real numbers. Another way you can write that in interval, we'll get to interval notation later, so don't worry about that. Quadratic, if you look, the domain, your x values, this can go on forever, right and left, but the range is limited, so this is interval notation. You'll see the lowest y point on this graph is right at 0, and then every other y point, it goes on infinitely upward. So the way you write that is you put a bracket on 0, it's like 0 is the limit, the lower limit, and then it goes up to positive infinity because it goes on forever. Again, we'll talk about interval notation a little bit later. Just remember, domain, x values, range, y values. So on the cubic ones, to the third power, that's all real numbers for both of them. So it's like to the first power and to the third power are both all real numbers. Squared, you have to worry about the range, and then the square root you'll notice you kind of got to worry about everything. So all the x values are greater than 0, right? So the way you write that is bracket 0 to positive infinity. And then the range values, the y values, are also all greater than 0, so they kind of have the same thing. But you'll notice, like if you just look at the point 0, 0, that's on every single graph. So that's not enough to indicate what it is. Same thing with 1, 1. That's on all three of these parent function graphs. So that is not necessarily enough information to determine what the parent function is just off those 2 points. All right, so I left this up here so that we can kind of reference it. Identify the parent function for each graph, then describe which transformation of the parent function it represents. So if you look at number 4 here, so let me move this out of the way. It's got this U-shaped parabola, so that is a quadratic function. So, right, quadratic. Great. And then how is it different than a regular quadratic one? Here's a regular one. So it looks like it's just the exact same graph, but shifted over 2 units. So we'll say left 2. That was easy enough. All right, let's scope out number 5 here. Oh, we got a few of them. So this one is just one straight line, which means it's linear. Oh goodness. Oh goodness me. Oh my. So a typical linear one starts right in the center and it has a slope of 1. It just goes up 1 over 1. So the only way this is different is it's down 3 units. And from that 3, it goes up 1 over 1. So it didn't change stretch or compression. All right, let's take a look at this last one. Okay, so I see this is one of those snaky looking ones, which is to the 3rd power. So we'll say cubic. Oh my goodness, again, cubic. But remember, a typical cubic goes up and to the right. This one goes down and to the right. So we will say reflected. We have more of those? That's good. No, we're good. We're good. All right. So now we're going to get into more of the domain and range. So domain are all our x values which are your right and left. Range are all of our y values, which of course are up and down. So then the way we write in interval notation is if it's included, if the point is included, you put a bracket there. So let's just put brackets around that. And that's going to sound confusing here in a minute, or you'll be fine. And if the point is not included, it will get parentheses around. And you'll see more of this like as we start going over examples here. So for 1 through 6, complete the following tasks. Identify the parent function, identify the transformations, and write the domain and range in interval notation. So looking at number 1, I see it's got that parabola U shape. So that happens when it's quadratic. So a typical quadratic function starts right at 0, and then it goes to 1, 1, and then 2, 4. So it would look like this. Now, how is ours different? it's shifted to the right, and you'll see it starts at 6. So we'll say right 6. Now, where do you think that comes from in the formula? What? It says -6. That shifts the graph to the right 6. Now for the domain and range. So this is to the second power, which means we could have limits. We will have limits on the domain and range. So domain is right and left, your x-coordinates. This could go on forever right and left. So we're going to say all real numbers for the domain. But the way we're going to write that in interval notation is all real numbers could be to negative infinity or positive infinity. So we're going to put parentheses, negative infinity, which is like a sideways 8. So it goes on forever to the left and forever to the right. So maybe you want to do the all real numbers symbol next to it too, to show that either way is fine. But interval notation is when you have the parentheses or the brackets. So if you're ever using infinity, you have to use parentheses because it doesn't, there's no limit to infinity. So the range, this is where we do have a limit. Range are our y values. Our lowest y value is at 0. So we're starting at 0. If it's a limit, you got to put it in bracket. Now it goes on forever upward, so it goes towards positive infinity. That was a doozy. I'm going to make myself smaller, and then we will try number 2. There we go. Cover up number 1. So you'll see this is a cubic graph right here. Because it's got the snaky shape, right? And normally our cubic graph crosses right through 0, 0 and 1, 0. So how is this one different? Well, if you look, instead of crossing at 0, 0, it's crossing at 0, 1. So it's shifted up 1 unit. And so look in the formula. Where do you think that comes from? It's +1. Okay, so that shifts it up 1. This one, right 6, but it was in parentheses. This one went up 1, and it's not in parentheses. I bet there's something to that. And remember, linear and cubic, where the exponent is a 1 or a 3, it's all real numbers for the domain and range. So we're going to write that in interval notation. Domain, all real numbers is written as negative infinity, positive infinity. Range, negative infinity, or positive infinity. Cool. All right. This is our linear function because it's just a straight line. So linear functions start right at 0, 0. They go through 1, 1, negative 1, 1. They have a slope of 1 in the parent function. So how is this different? Well, it goes through the same point of 0, 0, so it's not a vertical or horizontal shift, but it is steeper than our line. So this is stretched vertically. So let's just say stretched. And it's stretched by a factor of 3, and where we get that number is right in front of EX. And again, linear functions to the first or third power. Domain and range are all real numbers. Negative infinity to positive infinity. Because there is no limit on the x or y. I think we have 3 more of those. All right. Here we go. Another linear function, which the parent function goes through 0, 0, so it's no vertical or horizontal shift. But then it usually goes through 1, 1, 2, 2. So it usually looks like this. So linear. But what is the transformation? Well, you'll see it's flatter than our original parent function. So this has been compressed. and we compress it by a factor of 1/2. Because remember, if that number in front of the x is between 0 and 1, it's compressed. If it's greater than 1, it's stretched. So we can say compressed by 1/2. And linear functions are all real numbers for domain and range. Negative infinity, positive. Negative infinity to positive. Fantastic. All right, we have a square root one. This is our first square root. So we'll say, oh man, how many times do you think I'm going to do that? Square root. Now this one has limitations on domain and range. So a typical square root function starts at 0, 0, and then it goes to 1, 1, and it looks like this. So how is ours different? Well, you can see that it is flipped down. It's reflected. And then it's reflected across the x-axis. So domain and range, if you look, domain is all our x values. All of our x values are greater than 0. So 0 would be the lower limit. So here's how we're going to write that. Bracket 0. Right? Because 0 is a limitation, and it goes on forever to the right. So it goes towards positive infinity. And anytime you're using infinity, you have to use a parenthesis instead of a bracket. The range are all of our y values. So if you look, the highest y value is 0, and it goes towards negative infinity. So you're not going to write 0 first and then negative infinity, because negative infinity is like the low end of it. So you're going to start with negative infinity, and you're going to max out at positive 0. So that's how we're going to write that. That's the trickiest one we have today. Okay? So don't get too fearful. All right, last one. This is a quadratic function. Right, because you have the parabola. How's it shifted from a normal quadratic function? I would say the best bet for that is kind of like look at the vertex of it. It's usually at 0, 0. Here it's at -4, -2. So it's shifted left 4 and down 2. Great. Now the domain and range. So a domain is right and left. There's no limitation to it. It can go on forever to the left, forever to the right. So domain is going to be all real numbers. So we're going to write that as negative infinity to positive infinity. The range is our y values, and we do have a limitation on this. The lowest y value is at -2, and then it goes up towards positive infinity. So our lower limit is -2, and it goes up to positive infinity. Now, let's kind of look at our shifts and the actual graph. So it said we shifted left 4. I see a +4. Hey, if it's in parentheses, it's going to be your right and left shift. And then it was shifted down 2. Oh! So your vertical shift is outside of those parentheses. Okay, so here is the general formula for the transformations. So linear functions, you have the slope, intercept, point, slope, and standard. Quadratic is when it's squared, cubic to the third power, and then the square root has a square root. But you'll see some letters here. Like all these have an A in front. So A indicates if there is a reflection across the x-axis. Oops, I forgot x. Across x-axis. And how would it indicate that? Well, if A is negative, then it flips. If negative. All right. A can also tell you if it is a stretch or compression. Yeah, I mean, that's more of the slope. What else we got here? We got h. Here, let's go ahead and put the stretch and reflect, or stretch and compression. So stretch if a is greater than 1, and it's the absolute value. So, like if you had -2, right? That's just a stretch, but it's also reflected. Compression if it's between 0 and 1. All right, so that handles the A. Then if you look in parentheses here, we have the -h. So h indicates horizontal, which is right and left. So here's how I have to remember it. Because there is subtraction built into the formula, it's kind of the opposite in my head of what makes sense. So if it says -h, it's going to be shifted to the right that many units. If it says plus, we're going to shift left. All right, and then the other one, the k, that is our vertical shift. So if it says plus, we're going to shift it up. If it says minus, we're going to shift it down. All right, almost done. We're going to wait for this announcement.
Kaya Holke, please stop by the athletic office. Kaya Holke to the athletic office.
There you go. That's in the notes forever, I guess. Identify the transformation just by looking at the equation. All right, so here I see a negative in front of the x, so that just means it is reflected. All right, here I see the x squared plus 7. It's not in parentheses, so that's your vertical shift. So that would go up 7. Now, square root 1, it's grouped in it, so it's kind of like they're in parentheses. So if it's grouped inside the square root, that is the horizontal shift. So it says plus 3, which means we're going to go left 3. All right, I see a 2/5 in front of the x squared. That's smaller, that's between 0 and 1, so we'll say compressed. And we could say by a factor of 2/3. All right, then all we have is a number right in front of the x, and it's larger than 1, so we'd say stretched by a factor of 4. Okay, what else we got? Oh, we got a couple shifts here. I see a -1 in the parentheses, that's right or left, so that would shift right 1. And then I see this -6 outside of the parentheses, that's your vertical shift. So that would go down 6. That's okay, we got a couple things here. We got the negative in front, which means it's reflected. And 3/2 is 1.5, so it's greater than 1. So it would say stretched by a factor of 3/2. That's it. Yes, we did it.